Welcome to MSO's second webinar of 2026, Roofing Inspections and Coverage Considerations, presented by MSO's own Nils Deacon and Mary Beagle. I am Sue Quimby, Senior Vice President and National School Director for MSO. Joining me as host is MSO CEO and President Jan Seitz, and providing technical assistance is Cassidy Cody. Jan would like to say a few words.
So good afternoon to all of you. We have a record crowd. We are well over 120 attendees, and that is terrific for this important topic. I want to personally thank Sue, who kills herself to pull this off, but also thank Mary and Nils in advance of what I know will be great presentations. And of course, Cassidy, who has provided great support as well. So enjoy. And Sue, I'll turn it back to you to introduce. I think Nils is going first.
Please take a minute to look at the antitrust statement. We will not discuss or answer questions that might address any trade secrets. Copies of this are available for your reading pleasure if you have insomnia. Next is the disclaimer. It's offered for educational discussion purposes only, not insurance or legal advice. Copies of the slides are also available to anybody who would like them upon request. We'd like to thank our generous sponsors listed on the screen and on our website. They help us provide these quality webinars each year. Annual sponsorships are also available. Contact us for information. About the webinar, Nils' firsthand experience as an inspector for many years will have a clear understanding of roof types, components of roof systems, and roofing materials and costs, and some of the emerging roofing materials that support sustainability and boost energy efficiency. Nils has been with MSO for 50 years, 500 years? He's been here since 1981 as inspector.
Yeah, since kindergarten.
Yeah. He currently manages the inspections and rating service. He provides inspections for schedule rating and short form reports, and he's also a principal member on 3 NFPA Technical Committees. Nils?
Hi, everybody. Thanks for coming. That's my bio. Like Sue said, I am on some technical committees that help MSO with NFPA that help MSO keep track of new developments in the field and the standards that are applied to them. I use the following sources very much in this presentation. A lot of alphabet of letters, but they're all very important. So roofs cover us all, right? What would we do without roofs? And as a very wise man once said, that the time to repair a roof is when the sun is shining. We want to make sure that before the tempest comes in, that we have a solid roof to protect us, because water finds the lie. That's from a roofer, and it could also be from a plumber, right? If a roof has to be watertight, because if it isn't, you know it soon enough. Because roofs are a system. Every component works together, kind of like a sandwich, that it provides protection from the elements. We'll be looking at roof loss background, roof types, components of roofs, roofing materials and associated costs, the IBC, which is International Building Code, and inspection considerations. So there's been a significant increase in losses and claims with roofs to the insurance industry. Roof damage and claims saw a big rise in 2024. Lots of different sources provided a $31 billion figure for claims, which is about a 30% rise from 2022. So in just 2 years, 30%. And so what's the reason? There's been a rise in the medium-sized secondary perils, the SCS, severe convective storms. So we're talking about thunderstorms, tornadoes, and hail, and are actually cumulatively, they're driving losses more than the major hurricanes. And what's the reason? Well, climate change is brought out a lot. And that certainly is important. There's increased warmth, so higher levels of moisture. So that's fuel for developing thunderstorms. There's expanding seasonality. The warmer seas and oceans are extending these severe convective storm seasons. I heard on the Weather Channel, I believe that just so for this year, there were something like 14 cold records set across the country. But in the same time, something in the range of 30 to 40 high temperature records were set. So it really speaks to the increase in heat that we're dealing with. And which has led to that increase in convective storms and that predominance of that we're seeing in losses. There's other practical reasons for these losses and exposures. The urban-suburban expansion in the United States has increased 20%, according to my sources, from 2000. And 26 years ago, it doesn't seem that long to me when I think of all the infrastructure that we have and all the housing. So if you increase that by 20%, that's a tremendous amount of added exposure. And it's done in areas that were previously unused. Right, the easy areas, the places close into the metropolitan areas were easy to get to, or to water sources, but now they're going further out. You have to go further out from the metropolitan area to have land to develop, so that a storm that might have swept over an open field or a forest is now going through a densely populated area with residences and commercial occupancies and industrial occupancies. My son lives in the suburbs of Washington, D.C., out in Virginia. I don't know if you're familiar with it. There's the Beltway, which goes around the city itself, not really in the city itself, but beyond the Beltway, you go 20 miles out, and they're still developing it. They're reaching towards the Blue Ridge Mountains, and its development that includes housing and commercial and even big data centers. And plus, there's a vulnerable older housing stock, right? Well, all those houses that were built are still around, so that they're less resilient to hail and wind. Asphalt roofs become highly vulnerable to damage after just 8 to 10 years, especially to hail. And Gallagher Re came up with a figure of about 3.5%, or 3.5 times more likely to generate a hail claim than newer homes. And also, the older homes aren't built to updated code requirements. It's not always that they built them better back then, because it's not necessarily true. There's a lot of upgrades in the standards, like increased fasteners, nails, and hurricane straps and things like that really do build for a tighter structure. And plus, the total value of insured assets, homes, cars, commercial buildings, and all the associated belongings that people have has grown as part of that expansion that we talked about. So there's more things that are exposed to these storms. We've got more stuff. So now I'd like to talk about roof types, gable, hip, salt box, flat, and mansard, and architectural, but I'll really just be concentrating on gable and flat, because they're the most common that we run into. Gable roofs, right? That consists of the sloping sides on either end. There's a ridge at the top, and it creates a triangular section in the wall, which is called the gable, right? And it's the most common roof type in many regions of the country, almost all regions except Southwest, perhaps. It's very good at lots of things, right? It's Well, let me just go back because that steep ridge really sheds water and snow. Now you can see that this isn't actually a dwelling. This was a church I inspected a little while ago, but I like the dramatic sweep of the slope. Okay, the gable roof has lots of advantages. There's room for attics, for vaulted ceilings, and even finished living spaces up there. It's cost effective to build. It's a very straightforward and well-known design. It takes fewer materials and less labor than complex styles like hip roofs or mansard roofs. It's very good at weather stripping, shedding, as we said. It keeps water from pooling and heavy snow loads from building up on the structure. There's also very good natural ventilation. At either of those gable ends, there's usually a vent at each end so that there's cross ventilation, which keeps the attic area from getting too hot, which is important in the life of the roof. Also prevents a moisture buildup. There's a architectural versatility that it can be plugged into the Colonial and Cape Cod and Craftsman, so it can be adapted to modern designs. Other types, hip roofs, we do see that it's a very strong type of a design. It's very good for resistance to high winds. The four-way slope naturally braces the structure against lateral pressure, and we'll talk about lateral pressures and wind loads a little bit further on down the presentation. Here's just some elements of the roof. Now here's our gabled roof, right? That we saw. We'll talk about fascia and things like that and flashing. But here's that hip roof, and you can see that it comes down on that end and also on that end. And here's our flat roof. We'll talk all about that. Some other types of architectural roofs we see. It's primarily referring to the architectural shingles that are known as dimensional or laminated shingles. They put them together so it gives them a three-dimensional look, and that's used in the craftsman style that you might see in areas that they have a lot more front and cross gables, so that there's architectural features that are interesting. Other components are eaves, right? That's the lower edge of the roof that goes past the exterior wall. It helps to shed water and rain away from the walls. And then the soffit, the underside of those eaves. And a lot of times there's vent holes, or you can that allow for more cross ventilation and uplift into the attic to keep it from getting too hot. Flashing, that's an important component. It's the metal, usually metal, that goes against where there's a break in the roof plane, or there's a chimney or some other break in the plane of the roof, so that it's hard to put shingles up in there. And that's why they'll use flashing to make a tight seal and help it shed anything else, any water away from the roof. Another part is the drip edge. That's at the very perimeter of the roof. It's usually L-shaped, but also a T-shape like the one here. And I did not quite know it, but it breaks the surface tension of the water, so it'll drip off right away from the roof. Otherwise, it might back up and get underneath those shingles and cause a problem. The fascia, that's the vertical finishing board. It's easy to remember. It faces you. And this was a house in my neighborhood that had sustained damage after a straight line wind event that was up to 70 miles an hour. So it tore off my neighbor's the gutter that was hanging on the fascia. It also tore up part of the aluminum material on it, and you can see where it came down into a downspout. But that's what we're looking at here. And as far as flashing, you can kind of see it up on these bathroom vents. Okay, now I like to talk about flat roofs. They're horizontal or nearly horizontal. They do have somewhat of a slope, and that's part of code, so that they do shed water to a certain extent, and it helps to prevent pooling. It's very common for commercial and industrial buildings, as I'm sure that we're all aware. It's very cost effective, right? It's you don't have to have all the other materials that you actually have to have for gable roofs. It makes it's cheaper to build over a footprint of a large commercial or industrial building, and it optimizes space. These HVAC units that we see up here, that would take up a lot of room inside of the building. So you're able to put all these units up on top of a flat roof. It's also easier to access for maintenance crews or that either for those HVAC units or for some other reason. They don't need the special harnesses that are needed for gable and other pitched roofs. And they can also be good for usable amenities. They can serve as additional space for rooftop gardens, or maybe solar arrays or outdoor seating. And if you're lucky, an apartment building might have a roof on top of a pool on top of that roof. We'll talk a bit now about flat roof coverings and also gable or peak roof coverings. I'll start with torch down roofing. I find it very interesting for a number of reasons that we're going to be going through. They use a modified bitumen that you can see there. It's reinforced with fiberglass or polyester, and they use a torch that is used to heat the underside of those bitumen rolls, and it helps to make the heat melts the asphalt, and it lets it fuse directly into the roof substrate, and the substrate is the roof surface or the decking. We'll get into that a bit more. So it makes for a chemical and waterproof seal, which is really important, especially at the edges. You want to make sure that water can't get up under there to leak into the building. Those watertight seams are really important. It makes a very reliable, stronger bond than a lot of standard adhesives or nails, especially over a large area, because we want to make sure that there's no pooling of water, or at least that doesn't last for too long. And they're more durable. They allow for temperature contraction during the cold months, or expansion during the hot months. So they help keep from cracking and melting. Can there be fires caused by them? Yeah, there certainly can be. The torches get up to 1800 degrees Fahrenheit. There can be a delayed ignition issue, especially if it's on a wooden roof or one that has wooden supports. NFPA does have hot work operations for this, but I don't want you to think that it's a dangerous type of procedure. It's really pretty safe. Let me just stay on this. The roofing industry, the asphalt roofing industry especially, has a very good certification program. It's called CERTA, and every roofing professional, every worker that is doing that work has to go through the certification process. And since they started it halved any kind of problem, any kind of fires ignition that started because of this technique, which was actually very low to begin with. So it's really not a problem. It's a very efficient and safe way to apply roofing over a very large building. But there's other systems that you don't have to have open flame torches. There's rubber roofing, right? That's cold, or that's uses cold applied adhesive to keep the rubber held down. But it can also be used using screws and plates. The white TPO, which is here, we see a lot more of that. It's very present in a lot of the new roofing applications that we see. And the seams are joined with heat, but it's by a high-powered a hot air welder, which is kind of like a high-powered hair dryer. I've seen it described as. So it doesn't involve a flame or a torch. And there's PVC. It's very similar to that, and is also applied with heat welded hot air units. The old built-up roofs that you might be familiar with, those are being phased out because those are dangerous, if not really closely and expertly applied. Okay, now we'll get to asphalt shingles. It's the most common residential roofing material in North America. It's easy to install, and there's a lot of styles, a lot of colors. And the big stat I saw was about 80% of U.S. homes have asphalt shingles as covering. Just a description of it. It has a base mat. It's usually a fiberglass mat. It's very good for fire resistance. There's an asphalt layer on both sides, which helps with which provides waterproofing and durability. And those little mineral granules that you might notice on asphalt shingles, ceramic coated stone particles that are on the top layer, and they help protect from UV rays and also provide good fire resistance. Metal roofing coverings are getting very popular. It's a very high performance system, very durable, energy efficient, and can have a very long lifespan, 40 to 70 years or more. And historically, it was associated with industrial or other buildings, cultural buildings, and you can see this is a copper roof on the Asbury Park Carousel building, which is over 100 years old. You might come back to that picture. Okay, other metal roof coverings are steel. It's most common and very affordable. They add zinc to it, which galvanizes it, so to prevent rust. Aluminum, it's very good for salt water corrosion. If you live near the ocean, we get a lot of salt air, frankly. So it's very popular in coastal regions. Plus, it's lightweight. And copper, like the one that we saw in the Carousel building, it's expensive, but it lasts a very long time. It starts out as a bright penny color, and then it turns into a patina of blue and green, like you see here. And we may want to keep a look at because we won't be seeing many new pennies after a while. Okay, other advantages, like we said, they last a long time. Asphalt shingles, not so much. We're looking at about 12 to 20 years, maybe a little bit more, depending on the environment, but not too much more. Metal roofing is highly resistant to weather. It can take wind gusts up to 140 miles an hour, and also it's good with hail and snow. Energy efficient. It can reflect radiant heat, solar radiant heat, and help with cooling costs. And something, one question we did have is it more susceptible to lightning? My research says no. Lightning is more attracted to heights and other topographical features that isn't necessarily concerned with the actual material. So, so it's fire resistant, right? It makes sense. It carries a Class A fire rating as long as all the other components are compatible with it according to code. So it's very good for wildfire-prone areas. Sustainability, it can often be made from recycled content or partly recycled content, and then when they're done with it, it's 100% recyclable at the end of life. And fairly low maintenance. It doesn't rot or crack or support moss growth or mildew growth. And so inspections and debris clearing is kept to a minimum. Some of the disadvantages, though, right? It's big front end loaded cost. It costs 2 to 3 times more than asphalt shingles to install. So that's a major investment barrier that not everybody feels like doing. Noise, there can be a certain amount of noise if it's not properly insulated or on a good substrate or sheathing, and so rain or hail can be hurt a little bit more, and maybe even a cat on a hot tin roof could be hurt. That's my joke for the day. Expansion and contraction, if it's not installed properly with proper fastener room that gives a breathing room, it can loosen over time and could possibly leak. There is a certain amount of denting that can happen just from falling tree branches or large hail. Aluminum and copper can be subject to that a bit more. And it's the installation is more complex, right? You need to know what you're doing, have to have a different tool set and qualifications to install that. And there's a certain amount of corrosion risk if they get scratched for some reason, especially in a salty environment. Other roofing materials, clay and concrete tiles are very common in the Southwest. It's good for hot climates, or slate roofing. Might see a bit more on the East Coast. Very durable, long lasting, but very expensive and not very common. Other roofing materials that you've heard of: cedar shake, composite, and even solar panels that can be used as roofing. But I'm not going into them now because they're just not that prevalent for what we are dealing with. But I do like the concept of living green roofs. All right, they provide natural insulation and stormwater runoff. They soak up the water, and it helps to mitigate the urban heat island effect in cities. So they can be growing in popularity there. But there is a big disadvantage: extremely heavy, 15 to 30 pounds per square foot. So you can think about how much weight that would be on a 1,000 or 2,000 square foot roof, and because of that, they might require structural reinforcement. And they require easygoing maintenance, like weeding and watering. A lot of the code language that I will be quoting, or just briefly, is from the International Building Code, which is part of the International Code family that I showed you in the beginning of the presentation. And it's used for a lot of national, state, and municipal codes in the United States. And one of the big things that they really do want to make sure of is compatibility of each component of the roofing system. So the sandwich all has to go together to get what you want out of it. Excuse me. Insulation compatibility. The insulation has to be chemically and physically compatible with the roof materials. The adhesives and binders all have to that are used to seal the roof also have to be um, compatible with the roof substrate or decking. Fastener compatibility, that's very important for asphalt shingles. Or for metal roofs, we don't want copper nails on a roof that could react chemically. And we want good underlayment caps. That's what's holding the underlayment that we're going to be getting into so that they don't pull off. So some definitions: substrate. It's really commonly known as decking, roof decking. It's the structure that serves as the foundation for the entire roofing system. It's the layer that's of material that's above the rafters and trusses. So some of the materials used, oriented strand board. I frankly hadn't quite heard that technical language before. It's basically it's known as particle board, right? It's very cost effective, has an engineered strength feature that's very good. But then there's traditional plywood, very good at moisture resistance and dries out quickly. If you ever see a new house that's been constructed and if the roofers don't get to it before it rains, you might wonder what happens. But plywood might be a little bit better than particle board for moisture resistance, but they usually get to that pretty quick. Then there's metal decking. It's used a lot in commercial buildings. It's lightweight but fire resistive, and it can support that heavy equipment that we saw before, those big HVAC units, and plus a metal deck roof. If it has masonry walls, MSO would consider it fire masonry non-combustible. And if it's supported by reinforced concrete, then it enhances it even more. The underlayment, that's the water resistant or waterproof barrier that's installed between the roof deck or the substrate and the roof covering. So it's usually asphalt saturated felt. It can be synthetic material or rubberized asphalt. But you want to make sure that it's compatible with the roof deck and the final covering. So this gives you a good idea of some of the terms I've been talking about, right? This is a big roofing job. It's on a combustible wood roof. And we can see here is the substrate, right? That's the plywood boards. And you can see where here's some new boards that were put in. They replaced boards that were deteriorated, which is a very important aspect of re-roofing or recovery. And here's the underlayment. This is basically the felt paper, and then they're putting it in the shingles. That look like three-dimensional shingles, and here are the the bundles of roofing of shingles. Each one of those, it takes three of those to come up with a square, and a square in roofing is 100 square feet. Open valleys, the code addresses open valleys. We want it's basically a kind of flashing because it's where two roof planes meet in an open valley, and a closed valley doesn't necessarily need such tight flashing or metal flashing. Impact resistance. I found this interesting, that there's the steel ball test. And that's it's most common for asphalt shingles. It's for impact resistance, where they drop a metal ball that weighs about 1.15 pounds, 20 feet twice into the same spot to get a good rating. Factory Mutual does the ice ball test, where they shoot compress with compressed air these ice spheres onto wood or metal shake shingles and other shingles. Solar panels have to go undergo similar testing, and that's with a group I hadn't heard of before, but it's the International Electrotechnical Commission. Something good to know. Other tests would be the spread of flame test, see how far flame travels across a roof surface, an intermittent flame test, cycling flame to see if it eventually ignites, and more common burning brand test. They place a one block or brand to check for penetration. So it reproduces embers and flying brands that can happen in a wildfire event. I just wanted to give the A, B, or C of fire resistance. I think Class A is pretty impressive. They put a 4+ pound burning brand onto a roof, a 12 by 12 foot section of the roof, and see how long it can keep it off. And we're looking for 90 minutes for it to be a Class A fire resistance. And then just down to Class C, it's a little bit lot different, right? They're a third of an ounce, which is about 2 nickels. But that would be in an area where there's less threat of wildfire. But compatibility, again, is important. All of the elements have to go together for it to keep that Class A rating. Moisture and thermal management, they're concerned with R values. That R stands for resistance, right? It's resistance to heat flow, so that it's for heat blockage. It shows how it keeps cold air out and warm air, well, maybe vice versa. But it's it has an additive value that I think is good. So if you're laying insulation bats up in your attic and you can't get the R30s, you can put 2 R15s down and get the same effect. Insulation placement is also taken care of, and something that you might see a bit more for residents. The attic floor, that space between the floor joists that you would put insulation batting down, but it does require that it be vented, and so those roof vents or gable vents are very important. Okay, then it's important that they come up to standards that they're approved, right? Like UL, that they've been approved or they've been measured by these testing agencies, UL or ASTM, to make sure that they perform the way they're supposed to under environmental stress. And everything has to be installed and designed and maintained according to code, so that they work together again. Another maintenance issue to look at or inspection issue is to make sure that there's positive drainage on those flat roofs. Those certain minimum slope. Nowadays, it's about 2%, so that there isn't ponding, so that they do drain into those drains or scupperts. And good attic ventilation, as for peak roofs, perhaps that good ventilation, as I said before, prolongs the roof's lifespan, and it keeps ice and snow from building up and damming. That would stop good drainage. For attic ventilation, there's the ridge vent. Remember, along that ridge that I spoke about as one of the features of a gable roof. It's very efficient. It's because that's where the hot air gets up into, right, the very top of the attic. So we want to make sure that a lot of that heat can escape naturally. Those gable vents that we already talked about, a lot of times they're louvered, and they really are very good at providing cross ventilation. The soffits, we saw before. That's the intake vents for that ventilation. And if for some reason those don't provide the ventilation that you need, you can always get a powered attic ventilator. Okay, there's been questions, or always questions about what I've asked of a roofer. How many layers can I put on? Right, the IBC really limits it to 2 layers of roofing. One would keep from excessive weight loads, right? All those shingles can weigh a lot. You put 3 layers on, and that's a lot of weight. And plus, it's good to get underneath all the old shingles to see what that substrate or that decking layer, uh, how well it's doing, like we saw in the picture of the new decking. Physical inspection, it's you can get up there, and an experienced roofing inspector might have a pretty good idea about how old that roof is, but you can also maybe drill down and get even more uh, direct about by paid invoices and a repair history. So we would ask for those as part of a roofing inspection. Also, we're looking for any sagging of the roof or inadequate drainage or evidence of subpar past repair, where you can see patching was done, and take a look at those and see how well they were actually installed. And also look at those granular material on the asphalt shingles. Sometimes you can tell that when they've been washed off, that it's about how old the shingle might be. Also look at flashing, gutter, and soffit issues to make sure they're all in good shape. And then an interior check of the attic for ventilation or water stains and mold or insulation issues. Moss. I got a bad report card one time for my roof had moss on it, and from one of our companies for my homeowner's insurance, and sure enough, it sure did. Moss is a problem. It obstructs the natural flow of water off of the roof, uh, and it can make for some kind of ponding on the roof, or clogged gutters from all those moss fragments. Um, and when there's a freeze thaw problem, it collects the moisture, and then when it freezes, it can crack and makes the shingles brittle and plus heavy. So, like we said, the moss acts like a sponge. It holds water against the roofing material, which is a real problem. All that constant dampness can lead to decay of the shingle and the substrate or the decking underneath it, and even promote mold or bacteria growth. Structural damage. Moss has little root-like structures that go down into it, that creeps under the shingles and can make them curl up, and breaks that watertight seal. So the leak. So to reduce moss buildup, right? Cut back tree limbs. Moss doesn't like sunlight. Sunlight is its enemy. So we want to try to increase sunlight, and airflow is important to clear all leaves, any organic matter, because more, like I said, moss likes moisture. The Asphalt Roofing Manufacturers Association does provide guidelines on removal. They recommend a 50% strength of laundry strength bleach to water. Spray it on, or get it on some way. wait 15, 20, 30 minutes and rinse it off with a low pressure hose. We really don't want to use a power wash type of hose or tool on it that'll blow everything off the roof, including the shingles. So that's an important consideration. Uh, Structural design and slope inspection. So it's going to be uh, important that the inspector look at how well there's a gravity shedding of water, and to do that, we probably will look at the individual shingles. So it's looking at the individual shingle or tile integrity and make sure that they'll continue that gravity shedding of water. For commercial flat roofs, it doesn't necessarily shed naturally, has to be directed into drains. So we look for ponding of water, which is standing water for greater than 48 hours, because it can add a lot of weight and degrade the membranes. For residential inspection for shingle uplift and attachment, we want to watch out for high nailing or overdriven nails. High nailing is when the shingles are nailed above. Basically, there's a nail line in those shingles. So up too high, it can be in a weak part of the shingle, and it'll allow the wind to catch it and unzip it. For commercial, uh, if they're mechanically attached or heavy duty plates, want to make sure that everything is fully adhered with adhesives or balanced with gravel. And so you check the perimeter flashing, because you don't want the wind to come up and uplift and peel back whole sections of the flat roof. Excuse me. Other considerations with penetrations and equipment, right? In residential, not so much. We're looking at chimneys, plumbing stacks, or attic vents, but in commercial, there's lots of penetrations. Those HVAC units we talked about, right? They have to be properly sealed and flashed. There is a certain amount of vibration that has to be contended with. I want to make sure that the fasteners aren't backing out and to cause cracks in the membrane, and even foot traffic, like a lot of frequent maintenance that to fix those roof mounted equipment. We're looking for a walkway so that the workers don't have to walk over every part of the roof with material and other equipment. Of course, sometimes they leave all kinds of things up there. You can see that they left boards. They probably had those to when they were mounting some of those HVAC units as support, but they leave them up there. They can be moved around with the wind, can damage the roofing itself, or even blow off and hit somebody on the head. So we watch out for all that kind of stuff. Drainage systems. So it's mostly exterior gutters and downspouts for residential, but commercial, we're looking for internal drains and scuppers that let the water drain internally. But we want to watch out that it doesn't drain inside the building down the structural columns, because and so we're looking for the strainer baskets. This is all IBC. Clues, visual clues, it's easy to see, curling shingles or attic water stains for commercial. The leaks can travel a long way from the source on the roof, especially on the big roof. So there's use of infrared thermography and moisture probes to find that. And they can identify wet insulation that's trapped between the membrane, and it's a major factor in claims. Important to know about geographical regulatory considerations. Standard smooth shank nails they don't hold that well, right, under the intense pressure for hurricane, but even tornado and thunderstorms in coastal areas on New Jersey and the others. There's they use ring-shank nails. They have these ridges that help keep it from being pulled out. And these are 8D ring-shank nails, and 8D is about a 2.5 inch nail. I wanted to talk about the continuous load path or wind load path. It's the lick because it's an important engineering consideration that it's the link system of fasteners, wood that transfers the weight of the roof and the force of the wind or other environmental forces that bring it all the way down to the ground. It starts with the roof sheathing. Snow and ice hits the roof, right? The sheathing collects that load. Then it transfers it to the fasteners or the nails, and then the load moves on down from the sheathing to the rafters and the trusses via the nails. Those trusses carry the load to the top of the exterior walls, and those walls then carry it down, especially well if there's metal connectors, hurricane clips, or ties. They help lock those rafters to the top plate of the wall so the roof doesn't just flow off like a lid. Then it continues on down the wall and the sheathing to the vertical studs down to the floor. It hits the sill or the base plate and the anchor bolts. So you have all this force coming down and into the foundation, and finally it goes into the foundation and footing and distributed into the earth. I think it's a pretty cool engineering concept that is used importantly in code work. Other geographical and regulatory considerations, fasteners have to be penetrate 3/4 of an inch into the sheathing. Use of hurricane clips and straps is important as part of that continuous load path. It's mandatory in certain locations on the coast. I live in New Jersey, so I'm going to use that. They're looking for straps and clips, and especially in areas that can have high wind speeds of 115 to 120 miles an hour. Retrofitting, that is also an important thing. If more than 50% of the roof deck is going to be replaced, then they need to put in hurricane clips and straps and other enhancements. And there is a difference, right? That the hurricane ties that they require five nails. That all gets to be important because they require a 6-nail pattern in high wind zones. That's a little bit less than we saw before. And the underlayment has to be in high wind areas has to be attached in a grid pattern and a 6-inch spacing on the laps. And it's important because that all increases costs, right? Up to 10 to 20%. You're increasing the number of nails that you're driving in or whatever fastener you're using. And even though the nails don't cost that much, labor is the biggest driver, right? It costs longer to put in six nails than 4 nails. Just all the way, and it's kind of like a little cascade all the way down. But hurricane clips and straps, they add cost too. So we're talking about a 50. This is probably about 4 months ago. So with inflation, it's probably gone up. Permit fees are also to be taken into consideration. They need to be midpoint before all the decking or all the shingles are put down.
Hey,
Roof coatings. This is my last slide. There was some interest in about roof coatings, right? Roof coating, to extend the life of your roof. They use plant-based and other oils, but those can void the warranty for a lot of shingle brands like JF. And it doesn't repair that structural damage on the roof deck that may have occurred, and is really important to take care of. And it doesn't always follow the STM or the other codes for compatibility. They can be very slippery, so it's a liability issue. So really don't recommend it. Just general roof maintenance, clearing debris and drainage system, and proper attic ventilation to take care of that issue. And then with that, I'm done, and I appreciate your time.